Uh-oh. All right, we're gonna go here and here. Can I see it here? Nope, that's fine. Let me share screen. Oh, and we are back. So we only have about 10 minutes left, and that's approximately correct. We got about 10 minutes left in class. So I'm gonna do the best I can with these 10 minutes. I had a plan for some extra credit, but I need people to show up. And if they don't, and I warned them, I was like, look, we're gonna get booted. I'm coming right back. So we'll see. We'll see. It depends on what the numbers are looking like. If people don't show up to the second one, I'm not gonna worry about it. I'm not gonna worry about it. I was just wanted to try to reward those that were here. But anyway, okay, so again, we only have about 10 minutes on the section, so we'll do the best that we can. Again, the full details are in my pre-recorded lecture, single page. But yeah, that little, just that thing is disruptive, man. Anywho, yeah, we're gonna go with it. Oh, I don't know why it always does this. Okay, so where we left off, right here. Okay. So the X minus first item, right? So the approximate cost of the next item, the marginal cost, right? In order to produce X amount of items, the next item costs this much. The marginal revenue is given by R prime. And I think that's supposed to be an X plus first. I think that was X minus. I think it's supposed to be an X plus, right? It looks like a typo right here. I thought it was kind of right here. This is a typo. That's supposed to be a plus. Let me see. Did anybody make it back? No? Okay, that's fine. All right, that's supposed to be a plus, right? So the X plus first item, the next item. Yeah, that's better. The money generated from the sale of the X plus first item is the marginal revenue, and the marginal profit is the overall profit of the X plus first item. Okay, which is given by P prime. Okay, and again, these are approximations. Okay, so given this cost and revenue function, find the total profit, total cost, revenue and profit from the production and sale of 50 units, and then the marginal cost and revenue and profit when 50 units are produced and sold. So the total profit will be revenue minus the cost. So if we, I'm just going to put it here. Our total profit, this is fine. Yeah. So revenue minus the cost. So basically, I'm going to combine like terms. X cubed. There's going to be the negative 12x minus 62 to give us some 62, 72, 74. So minus 74x squared. Revenue. So then 40x. So 10 minus 27,500. 27,490. So negative 27,490. I don't know. Yeah, I had a plan to give extra credit, and I told these guys I'm coming right back. So I don't know. I do not feel inclined to do it. You gotta show up. You gotta show up. All right. Anyway, so this looks like our total profit function. So we're gonna go with that for part A. I'll just let this be for part A, and then part B I'll start it here. Total cost, revenue, and profit from the production and sale of 50 units of the product. So basically, plugging in 50 into those guys. Right, plugging in 50. I think I'm gonna use my calculator. I think I actually just use my prepared notes, right? We're just plugging in 50 there. The marginal cost revenue. And so then for the marginal cost revenue and profit, we basically take the derivative and then plug in 50 into the derivative, right? So I'm just gonna say use a calculator. I'm just say calculator for part B. Now, we need to find the derivative of each of these guys. So P prime. 3x squared, 140, 148 plus 40, okay? And then C prime, 124 Okay, that's it for that one. And then R prime. 3x squared, 24x plus 40. And then we need to evaluate each of those when x is 50. I'm going to use the calculator for B and for that. So just use your calculator, because once you have those derivatives, you just plug in 50. And that should be the result. And we can confirm those results here. Let me see, x cubed, 74x squared, plus 40x, plus 10. Yeah, I think that's what we got, negative 27,490. So our total profit was good. B, we're just plugging in 50 into those equations. So we got those results, okay? And then the marginal cost and revenue, we take the derivative and then plug in 50. So 124x for the first one. For the cost, that's good. Yeah, I think we're good, right? We get the concept. I didn't exclusively take time to crunch those numbers. Oh no, actually, we're supposed to go to 715. Like with this cutting off, that's cutting us short. But I guess if people aren't here, then okay. So because people aren't here, I'm just gonna default to because there's no need for me to talk because I'm just talking to myself. Because you know, these details are in my pre-recorded lecture. So I'm still like this about attendance, like because people didn't show up. Class last out at 7:15. I'll cut up some slack because we're going into spring break. We still got a full 30 minutes left. You know what I mean? I'll cut some slack because we're going into spring break. But if I see stuff like this again, I'm gonna start marking it. I'm marking people as absent. And plus, I know we're rapidly approaching like a purge. Like if I just submit those names, it's going to be bad. Like people get booted and they may or may not be able to get back in. Like it's really dangerous to not show up because then that's money. You know, that's money. So for this, why? Let me see. Yeah, I think that since nobody's here, I think again because anything that I would say live is already in my recordings, and I know that you guys can use that. I'm just trying to glance to see if there's anything. The derivative is approximately the change in y over change in x. And so that you can approximate the change in y by f prime times delta x, that's fine. So this delta x is just a change in x, like x2 minus x1. And I want to say that delta x is equal to dx, but delta y is approximately equal to dy. Delta y is the exact change between the 2 points, but our dy, there's usually like some nominal difference between dy and delta y. That's the main thing here. This is an interesting one. So you definitely want to use my recording there. Just trying to glance and see. And yeah, these get a little bit involved, but again, those details are there. Okay. Oh, the linearization, man, that's a good one. So given this function, and let y equal f be a differentiable at x equals a, then a linearization of f at x equals a is given by y equals f of a plus f prime. Remember, f prime is your slope. So this looks like the point slope formula. All right. F prime is the slope, x minus a plus f of a. All right. So that's like that's an extension of the point slope formula. This equation is the equation of the tangent line of f at x equals a. Now I'm at a different room. No, I think it's the same room. Yeah, I don't know why it like you know. Anyway, it is what it is. I'll be gentle today. I'm not gonna because we still had a lot of time. We still got like over 30 minutes, but I know it's gonna cut off again, and I don't feel like going with it. This is a good one though. So again, this one is in the recording as well. These are good. So I am going to go ahead and call it a day. Yeah, I was originally I was open to extra credit for people that were here, but since nobody showed back up, after I warned everybody several times, like, hey, I'm coming right back, so don't go anywhere. People decided they're not coming back. Then I'm not inclined to give extra credit, but I'll just give people credit for attendance that were here in the first session. And you know, but again, you gotta make an effort to be here. Like even if we get booted, and especially if I say I'm coming right back, you know, I don't understand why it's not letting anybody in. But I'll go ahead and mark people as present, and we're gonna go ahead and call it a day, gentlemen. All right, so take care. Have a good spring break, and I'll see you in a little over a week, in about 10 days. Take care. Peace, love, and light.